Okay, welcome to the Checkpoint Review Help. I'm going to start off with a question 10. For me, it says, use the scenario in the diagram to answer the question. Patrick is practicing his aim in golf. His brother tells him that the angle he hits the ball is at 45 degrees to his right, and that the distance the ball travels to point C is equal to 8 square root of 2 yards. He was aiming for point B. So here's Patrick, here's where the ball went, and this was actually where he was aiming. What is the distance he should have hit the ball? So I'm looking for the length of little c, and the reason why this side is labeled little c is because it is opposite the angle C. So if you were to draw a straight line across from angle C, the side opposite that is labeled little c. Same for angle B. The side opposite angle B is called little b. That's how you would traditionally label a triangle. So this is a 90-degree angle, so it's a right triangle, and there's also a 45-degree mark. So in a 45, 45, 90 triangle, there is a relationship of the sides. If this was 1, this distance would be 1 over the square root of 2, which is also equal to the square root of 2 over 2. And this is the square root of 2 over 2. And so that is since every 45, 45, 90 triangle is similar, we can set up a proportion statement. So I'm going to start with the side, I'm going to start with corresponding sides. So C right here would correspond with this side. So I'm going to set up a proportion. The square root of 2 over divided by 2 is 2, well, time out. I want C to be in the numerator. So I'm going to start my proportion with C, and the numerator is 2 the square root of 2 over 2 as, alright, this length, our hypotenuse, 8 square root of 2 divided by is 2, and this hypotenuse length is 1. Now 8 square root of 2 divided by 1 is 8 square roots of 2. So this is just a number. Since I'm solving for C, and it's being divided by the square root of 2 halves, I'm going to use the multiplication property of equality and multiply by the square root of 2 to both sides. Alright, the square root of 2 halves times C divided by the square root of 2 halves is the square root of 2 halves. C divided by the square root of 2 halves. Now, square root of 2 halves divided by the square root of 2 halves is a form of 1 because it is the same number being divided by itself. No matter how funky it looks, square root of 2 halves and square root of 2 halves is the same number. So that makes a form of 1. So then we have 1C on the left, and that is going to equal, we have 8 square roots of 2 divided by 1 times the square root of 2 halves. So I can write that just as is. And I'm going to note that anything divided by 1 is left unchanged. So this is 8 square roots of 2 times the square root of 2 halves. And I'm going to use a Google calculator to help me simplify, because it says round to the nearest hundredth. So we're going to go to Google and we have 8 square root of 2, close that parenthesis so it's black and not gray, times parentheses square root of 2, close it again so it's black, divided by 2, close parentheses. That's going to equal 8. So we have his actual distance is, since we have 1c equals 8, 1 won't change the value of that, so in math it is traditionally just written as c equals 8. So c equals 8, that means the ball should have only gone 8 yards. So my tip to you is to put the 45, 45, 90 reference triangle with the side lengths labeled so that you can use them to set up your proportions as a quick reference. Or even better, memorize it. Alright. Use triangle ABC in which measure of angle A is equal to 57.6 degrees, measure of angle B is equal to 42.12 degrees, and measure of angle C is equal to 80.28 degrees to answer the question. What is the longest side of this triangle? Alright, I am going to think back and remember that there is a relationship between angles and their side lengths. And the largest angle will be opposite the longest side, because there's, if you think about a door hinging, open, I'm trying to think of how to draw this. Okay, so if you were to look straight down when you were opening a door and it made this angle, this distance is shorter and this angle is smaller than when you have the door all the way open. When the door is all the way open, mine usually make a 90-degree angle, and this distance is a lot longer than when it's not fully open. So that's how I remember the angle relationships, is just the biggest angle will have the longest side, the smallest angle will have the smallest side, and the angle in between will have the distance in between the largest and smallest. So I'm going to look at the largest angle, which is C, at 80.28 degrees, and its opposite side is labeled little c, which it can also be labeled as segment AB. So segment AB is the longest side of this triangle. Use triangle ABC to write the value of sine B as a ratio. Okay, this gives us our angle of perspective, which is from angle B. So from angle B, I'm going to label this triangle. Angle B, if I go directly across, that's the opposite side. The one right next to it, connected to it, and not across from the 90, is the adjacent. And the one across from the 90 is the hypotenuse. So sine of B is equal to the ratio of the opposite side over the hypotenuse, which would, by substitution, equal 12 divided by 13. Use the scenario in the diagram to answer the question. Zhao Qing is standing in the southeast corner of a rectangular park, and her friend Ji is standing at the southwest corner. There is a tree at the northeast corner. Ji is 24 square root of 5 feet from the tree. The angle formed between Ji and the tree and Zhao Qing with the tree at the vertex is 30 degrees. So here's the diagram. Southeast corner, southwest corner. Here's the tree, and they have it labeled. And so this angle is 30 degrees, and therefore this angle is going to be 60. And so we have another special triangle. 30, 60, 90 triangles will always be similar to each other. And those side lengths are 1, 1/2, and the square root of 3/2. So I would use that as put it in your notes if it's not, so that you can use it as a reference. So now I'm going to set up a proportion for what they want. They want to find the distance between Ji and Zhao Qing. So they want to find this, and I'm going to call it little t, since it's opposite the angle labeled tree. Tree starts with capital T. So then I'm going to set up a proportion, and I'm going to notice this 30-degree angle has to match up with my 30-degree angle here in order to set up corresponding sides. So little t's corresponding side is going to be opposite the 30-degree angle in my reference triangle. So this is the 1/2. So little t is to 1/2 as this hypotenuse is to this hypotenuse, and I'm using the hypotenuse lengths because those are the ones I have measurements for. So I have 24 square roots of 5 is to 1. So again, 24 square roots of 5 divided by 1 is 24 square roots of 5. And we have t divided by 1/2. I'm going to use the multiplication property of equality here. Multiply by 1/2 and multiply by 1/2. So then I have 1/2 times t divided by 1/2, which gives me 1/2 t divided by 1/2, which equals 24 square roots of 5 times 1/2. So 1/2 divided by 1/2, it's the same number being divided by itself. That creates a form of 1. So I'm left with 1t is equal to, and 24 square roots of 5 is a number. It's in exact form, so it's not rounded. But they want us to round to the nearest hundredth, so we can use our calculator. 24 square root of 5, close the parentheses, times parentheses 1 divided by 2. That's going to equal 26.83. and I'm going to go to the thousandths because I believe they want it to the hundredth. Yep, nearest hundredth. So then I look at the thousandths and I ask myself, is this a 4 or lower or a 5 or higher? And it's a 2, so it's lower than 4. So that 3 stays the same. So the distance between Xi and Zhaoqing is equal to 26.83 feet. And your quote for this checkpoint is by Christian Neville Bovey. It states, "Hard workers are usually honest. Industry lifts them above temptation." And we'll jump to question 4. Use the following right triangle with a hypotenuse that is 55 centimeters and one leg that is 33 centimeters to answer the question. What is the perimeter of the triangle? Okay, so it's a right triangle, and I'm missing a side length, and I have no other angles provided besides a 90-degree angle. And there's one theorem that I know that you can use to find the side lengths in a right triangle, which is the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So I'm going to label my 90-degree angle C, big C, and I'm going to have big A and big B. And the reason I chose the 90-degree angle to be big C is because I know in the Pythagorean theorem, this little c, side length C, represents a hypotenuse. And they are always opposite. So little a is here and little b is right here. So by substitution, I don't know what little a is. That's what we're trying to find. We know what little b is. It's 33 centimeters squared, which is going to equal, and little c, that distance is 55 centimeters squared. So, I'm going to, since I want to solve for little a, let's simplify ours. I'm not going to simplify these squareds because they're going to be really, really large numbers, and it's difficult for me to write that down, but we can just manipulate it as the number 33 squared. So since 33 squared is being added to a squared, I'm going to use the subtraction property of equality and subtract it from both sides. So then I have a squared. 33 squared minus 33 squared will be 0. That's going to equal 55 squared minus 33 squared. The reason I didn't take 55 and subtract 33 is because 55 is being squared, and exponents are higher on the order of operations than subtraction is. So I would have to do my exponent first before I subtracted 33 squared. So then I have a squared plus 0. Adding 0 doesn't change that value, so I have a squared, which equals, now I'm going to use our calculator and type in 55 squared, so I hit the x to the y, minus 33 x to the y squared, and that equals 1,936. Now, this is a squared, and the inverse operation of a squared is the square root. So we're going to square root both sides. So the square root of a squared is a, and that's going to equal, what is the square root of 1,936? 44. So, A's distance is 44. Now the question asks, what is the perimeter? The reason I needed to find the side length is because the perimeter is the total distance around the triangle. So I have to add 55. So perimeter is going to be 55 plus 44 plus 33. So 9, 10, 11, 12. 9, 10, 11, 12, 13. So we have 132 centimeters for our perimeter.